Hello everyone, welcome back to the channel. Today, I want to talk about a shocking development deep in the Russian Far East. Over 100 zero people plunged into darkness near the border with North Korea following what is being described as a blast at a major power facility. It may sound like something out of a disaster film, but this event appears very real. A sudden, large-scale blackout, people left in the dark in remote, frigid regions, infrastructure stretched thin, and authorities scrambling. Let's walk through what is known so far, explore the possible causes, look at the impacts and implications, and ask what this might tell us about energy, security, and broader dynamics in that region of the world. The affected area is remote but strategically important. In the far east of Russia, near the border with North Korea, lies terrain that is rugged, sparsely populated, and in severe winter conditions for much of the year. When a power plant or major transmission line fails here, the effects cascade quickly, heating, lighting, essential services all at risk. The accounts reporting 100 plunged into darkness refer to a blackout triggered by what is described as a blast at a main power plant. Sources such as a recent video titled Chaos in Russia, 100 Russians plunged into darkness near North Korea as main power plant blasts, claim that the incident shut off electricity for a large population. Why does this matter beyond the immediate hardship of the blackout? First, infrastructure vulnerabilities. In remote Russian regions, the electricity grid is exposed to few redundancy options, harsh climate, high maintenance burdens. A blast at a key plant or a major line fault can knock out power for many. That means hospitals, heating systems, transport, communication all can falter. Second, geopolitical context. Being close to North Korea adds layers. Proximity to strategic border, military facilities, perhaps older Soviet-era infrastructure, limited logistics support. Third, human cost. For tens of thousands of households, being without power even briefly in winter cold is dangerous. It reveals how quickly normalcy can slip away. Let's talk about possible causes of such a blackout. The blast at a main power plant suggests something like an explosion, failure, or sabotage. It could be a mechanical failure, e.g., boilers, turbines, switchgear failing under stress. It could be a natural cause issue, extreme cold causing equipment freeze or lines snapping under ice. Or it could be malicious, a cyber attack, a physical attack, sabotage, or unintended consequence of military activity. We don't yet have confirmed independent verification of all the details, so there is caution needed. The reports come from video channels and social posts. For example, a post on X referenced the event. 100 Russians plunged into darkness near North Korea. If it is sabotage or cyber attack, that introduces major implications. State infrastructure is vulnerable. The idea of a large population cut off from electricity in a remote region suddenly is a weakness that adversaries might explore. Alternatively, even if it is not intentional, the incident reveals how aging infrastructure and extreme environments can combine to create large crises. There is the possibility of cascading failure. One plant goes down, others are overburdened, lines trip, loads shift, and thus a wide blackout results. What are the immediate impacts of such an outage? For the residents, lighting out, heating out, perhaps water and sanitation issues if pumps stop operating. In wintertime cold, this is not just inconvenience, it is a public health hazard. Emergency services may be hampered, communications down, transport limited. For local industry and economy, production halted, supply chains frozen, costs rising. For the state and regional government, reputational damage, political risk, increased demands from the public for explanation and compensation. For national security watchers, questions about resilience and grid security, let's zoom out and consider the broader significance of this event. One dimension is Russia's energy infrastructure in the Far East. Russia has vast territories, especially in Siberia and the Far East, where infrastructure is thin and often exposed. Managing power generation, transmission, and distribution in remote cold regions is a perennial challenge. This outage underscores that even in modern times, such infrastructure remains fragile and can suffer large-scale failure. Another dimension is border region significance. Near North Korea, the remote region may see military logistics, strategic installations, and less redundancy in civilian infrastructure. That raises the stakes. An outage could affect not just civilians, but also operations tied to state interests. Another dimension is the precedent and signal effect. When one region suffers a major blackout due to plant failure or explosion, it raises awareness about what else could go wrong, whether by accident or deliberate attack. That in turn may spur efforts to harden infrastructure, raise response capabilities, or rethink decentralization of power generation, e.g., microgrids, regional backups. We should also reflect on how such an incident gets reported and how credible the information is. The initial sources seem to be media outlets, mainly video channels and social media posts referencing 100 Russians plunged into darkness near North Korea. But verifying the exact cause, verifying the number of affected people, the identity of the plant, the nature of the blast, the timeline and official response are still unclear. This raises key questions. Which plant exploded? What was its capacity? How many people were directly dependent on it? What contingency systems were in place? What is the official statement from local and federal authorities? Without these answers, we must treat the initial reports cautiously, though the scale of claimed impact invites serious attention. Moreover, the timing is worth noting. In the context of global energy stress, supply chain disruptions, increased cyber threats, geopolitical tensions, infrastructure attacks have been rising in many contexts worldwide. While there is no public official confirmation yet that this was sabotage, the possibility cannot be ruled out. The fact that a major outage occurred near a border region with higher strategic significance adds to the intrigue. In that sense, this event may reflect the intersection of energy, infrastructure, security, and geopolitics. Let's imagine what the near-term response might entail. First priority, restoration of electricity. The operators will need to inspect the facility, assess damage, reroute power flows, bring backup generators online, notify customers, coordinate with local authorities for hospitals, emergency, heating, and so on. Second, stabilization and relief. Ensure vulnerable populations, elderly, children, hospitals have warmth, power, or alternative shelter. Third, investigation. Determine the cause of the blast/failure, mechanical fault, human error, sabotage, external attack. Fourth, public communication. Authorities will need to explain what happened, reassure the public, outline steps for prevention of recurrence, set timelines for full restoration. Fifth, longer-term lessons. Reviewing infrastructure resilience, redundancy, emergency protocols, crisis communication, alternative power sources, grid segmentation, community preparedness. This incident may also carry lessons for other regions and countries. For instance, remote regions with harsh climates and aging infrastructure are inherently vulnerable. Even a single-point failure, e.g., a major plant, can cascade into widespread outages if the network lacks redundancy. The proximity to strategic borders or contested zones may further increase risk, either from neglect, underinvestment, or external threats. Therefore, investing in distributed energy systems, microgrids, alternative renewable generation, smart grid technologies, and robust emergency response can be critically important. Another takeaway: public awareness and preparedness. Communities used to reliable power may not appreciate how vulnerable they are until a major outage. Being prepared for alternative heating, lighting, communication, and transport in a blackout scenario, especially in cold climates, is wise. Another takeaway: transparency and communication matter in a crisis. The speed of reporting, accuracy of information, and response coordination all influence public trust and the effectiveness of relief operations. Looking ahead, what might be the broader ripples of this outage? One ripple is economic. Energy disruption in remote regions can slow resource extraction, industrial operations, logistics, and cause cascading costs. Another ripple is political. The local and national government may face criticism for infrastructure failures, neglected investment, and poor preparedness. That could push accelerated investment in grid modernization, but at a cost. A third ripple is strategic. Adversaries or malicious actors may see outages as vulnerability points. This could encourage efforts, cyber/spoofing/physical, aimed at infrastructure to create disruption. Hence, there may be increased funding and emphasis on infrastructure security, especially in border or remote regions. A fourth ripple is public confidence. Large outages erode public trust in institutions. Restoring that trust requires good communication, timely action, and visible improvement. Now, let's explore the human dimension more closely. Imagine a town in the Russian Far East, outside of the main metropolitan hubs, reliant on a single major plant for electricity. Temperatures drop. Heating systems depend on electricity to pump hot water or circulate steam. Families wake up to darkness, heating offline. Hospitals may operate on backup generators, but capacity is limited. Some residents reliant on electric pumps for water may find taps dry or freezing. Traffic lights out. Transport disrupted. Communications may falter if mobile towers lose power or backups are insufficient. In such conditions, the community must band together, neighbors help each other, local authorities set up warming centers, perhaps schools open as shelters. The psychological impact is strong. When a blackout is prolonged in extreme cold, fear and urgency grow. The sense of normal life being fragile becomes acute. From the governmental side, regional leadership must quickly prioritize restoration. They may deploy mobile generators, temporarily take less critical infrastructure offline to prioritize hospitals and heating. They will monitor public safety hypothermia risk, fires from alternate heating sources, carbon monoxide poisoning if people use heaters improperly. They will likely issue advisories: conserve energy, avoid non-essential use, stay indoors, check on vulnerable neighbors. Meanwhile, the plant operator will assess damage. Did equipment explode? Was there a fire? Are there structural damages? Was the blast external or internal? Are lines damaged due to weather or other causes? What is the expected timeline for partial and full restoration? These decisions happen under pressure, with public expectation mounting, media attention rising, and lives at stake. Another intriguing angle: escalation of responsibility and accountability. If the cause is found to be mechanical failure due to poor maintenance or aging infrastructure, then budgetary decisions come into play. Why was this plant so vulnerable? If the cause is sabotage or cyber intrusion, then it raises questions of state security, defense funding, intelligence assessments. If climate or extreme weather triggered the failure, does this prompt upgrade to climate resilient infrastructure? The finding will shape policy responses going forward. We can also think about parallels from other countries. Blackouts in extreme conditions have happened globally. In cold climates like parts of Russia, Canada, northern US states, Scandinavia, or very hot climates like the American Southwest or Middle East, infrastructure is challenged. For example, when a windstorm or ice storm knocks out power lines, backup capacity and grid design determine how quickly and widely the outage spreads. The lesson here, redundancy and decentralization matter. Microgrids, local solar plus battery storage, modular power generation near communities can reduce dependence on single large plants. In this Russian case, the reliance on one big facility near a remote region appears to be a weakness. Let's consider what the local residents might ask or expect now. Will I have heating restored by tonight? Is my household at risk of damage due to freezing pipes or power surges when restoration happens? Will there be compensation for losses? Will authorities take steps to prevent a recurrence? Are there warnings or drawing of lessons? Will there be greater transparency about grid health and maintenance? These are valid expectations, and the credibility of local government may hinge on how well it responds. We should also ask, are there longer-term demographic or migration implications? In remote regions where essential services are cut or perceived as fragile, residents may consider relocating to more stable areas. 1F. Businesses may avoid investment, slowing regional economic growth. That may accelerate depopulation of remote areas, a trend already seen in various parts of Russia. Conversely, a strong recovery response can reassure people and perhaps attract investment in infrastructure upgrades, creating jobs. Another question: what about external observers, investors, analysts, foreign governments? They may view this outage as a signal of Russia's infrastructure vulnerabilities, particularly in remote and strategic border regions. They may factor this into risk assessments for projects, resource extraction, logistics, defense readiness. It may also influence how neighboring countries view stability along the border and the potential for spillover effects. There is a risk of misinformation or incomplete information. When a large outage is reported with dramatic scale 100,000 people in darkness and vague details, blast at main power plant, it invites speculation. Was this orchestrated for dramatic effect? Was the number of people or cause exaggerated? Are authorities deliberately withholding details? In such situations, the media ecosystem and social platforms propagate narratives. Some may be true, some not. It's essential to await verifiable data, exactly which plant, the damage specifics, how many households affected, and official timelines. Until then, while the story is plausible and worrying, one must maintain a degree of caution about final conclusions. From a production standpoint, if we're reviewing this as a video topic, here's how I'd frame it for viewers. Start with the dramatic moment, a remote Russian region plunging into darkness, people waking up to no power, heating off, a blast reported. Then zoom out to explain the region, its importance, its vulnerabilities. Then dive into the technical side. What kind of plant might have exploded? What grid design issues exist? What redundancy is or isn't in place? Then explore the human story, what residents face, what logistics and support systems respond. Then examine the strategic lens. Border region, infrastructure, state credibility, security implications. Then consider forward momentum. What happens next? What lessons may be learned? What the broader implications are for infrastructure resilience globally? Finally, invite the viewer to reflect. What would you do if your power went out in frigid conditions? Are our power systems in our own countries vulnerable? What can communities do to prepare? Let's bring this back to some concrete numbers and situational details, recognizing again that full verification is pending. The 100 plunged into darkness, a figure, if accurate, means a very significant outage for a remote region. The outage appears tied to a blast at a main power plant close to the North Korean border. The region is likely part of Russia's Far East territories. The video report is fairly recent and suggests chaos and confusion among residents. Given the remoteness, bringing mobile generation, replacement equipment, or skilled crews would likely take time, making restoration slower than in more accessible regions. The cold conditions exacerbate the urgency. Freezing temperatures can damage infrastructure pipes, boilers, heating circuits, and people's health is at risk. If power/heating are off for extended periods, this isn't just about inconvenience, it's about survival. We must also consider the domino effect. If a large plant fails, other plants may be overloaded. Transmission lines may pick up extra load, fail in turn, causing wider outages. If the outage lasts long, the public may resort to unsafe heating methods, open fires, unventilated stoves, increasing risk of fire, or carbon monoxide poisoning. Critical services like hospitals and clinics may be pushed to the edge. Transportation may be limited, traffic lights out, public transport disruption. Communications may be hampered. In remote regions, supply chains, fuel, food, medical supplies may depend on power for refrigeration, lighting, logistics. An outage thus threatens multiple layers of vulnerability. On the infrastructure side, older Soviet-era power plants and grid systems dominate many remote Russian regions. Maintenance may be difficult, spare parts scarce, skilled labor limited. Harsh winters impose huge demands, heating loads high, transmission losses greater, risk of icing or line breakage higher. As such, the system has less margin for error. A blast or major failure thus can trigger a crisis quickly. The proximity to North Korea means additional complexities: terrain, cross-border logistics, strategic installations, potential military or civilian dual-use infrastructure. Access might be more difficult for external repair crews. Government prioritization may favor major centers over remote towns, delaying response. Let's also reflect on the public reaction and narrative implications. For residents, this kind of outage highlights a mismatch between expectations of modern infrastructure, constant power, and the reality of fragility in remote areas. It may spur anger, demands for accountability, protest, or migration. For the government, the incident becomes a test of administrative capacity, crisis communication, restoration speed, warning systems, and transparency. If the response is perceived as slow or opaque, social trust may erode. For media and analysts, the event may be framed as emblematic of broader systemic issues: aging infrastructure, underinvestment, over-reliance on single installations, geopolitical vulnerabilities. For external observers and foreign policy analysts, the incident may serve as a case study of how infrastructure intersects with national security, especially in border zones or areas of strategic importance. What are some of the questions we should ask? Which power plant was involved? What is its capacity, age, and role in the grid? Was the blast due to internal fault, external attack, sabotage, extreme weather, what emergency backups were in place, how quickly was partial power restored, how many households or businesses were affected, were there casualties or secondary failures, fires, heating loss, medical equipment failures? What communication did authorities provide, and how transparent were they? What will be done to prevent recurrence, upgrade, decentralize, add microgrids, strengthen maintenance, early warning systems? Are there economic costs being assessed, lost productivity, compensation, damage to equipment? What are the security implications